Hi, I'm Alistair, and in this video I'd like to describe a project you can make using a pressure mat sensor, an ESP32 and a monitor that's displaying a Node-RED dashboard. Now, normally in these videos I would describe how you could create an escape room puzzle based on these props. So perhaps a player steps on a pressure mat at one end of the room. That's detected by the ESP32, which would trigger a video puzzle or a clue on a monitor at the other end of the room. Now, obviously with the current situation in the world, escape rooms aren't open, so I wanted to think of another application that would demonstrate that same basic functionality. Now, if you're watching this in the UK, you'll be familiar with this gentleman. This is Captain Tom Moore, who has been in the news a lot recently because he's been doing an amazing job fundraising for the NHS. He will turn 100 years old tomorrow, and he's been raising money by walking 100 laps around his garden. So what I thought I'd do is a little tribute to Captain Tom. I thought I would use this as a lap counter and get my kids to actually run around the garden. Each time they completed a lap, they'd step on the sensor, which would be detected by the ESP, and update a visual display of how many laps have been completed. Here's it in action. Okay, so let me talk you through the hardware I'm using. The pressure mat sensor itself, so this is normally sold as part of a kind of a burglar detection kit. So essentially it's got two large conductive plates that are slightly separated inside, and when someone steps down on them, it forces those two plates to come into contact with each other, forming a circuit. Essentially it's just a very big button. And it has two wires coming into it, which you can connect to a GPIO input pin and a ground pin, let's say. I've just accidentally squeezed it together there, so you've seen the counter go up. And you can read it just as you would any other sort of button. They're not very expensive to buy. This one cost about £10. You can actually make them yourself if you have 2 sheets of cardboard and some kind of tin foil or something like that as well. So mechanically, really very simple. Now, normally in these projects I would use an Arduino to register a button input like this, but in this one I'm using an ESP32 instead. Now, the reason why I chose this board instead, it works a very, very similar way to an Arduino. It has a different chip on board though, and this chip has built-in Wi-Fi. So the reason I've chosen that is because I want the mat itself to be positioned somewhere in the garden, and if I connect the ESP32 to a battery and that to the sensor, I can kind of position this anywhere I want. When the mat is pressed, it will be detected by the ESP, and that will trigger a wireless signal over the network to my laptop, which is connected to the display here. The display itself, so this is running a Node-RED dashboard. Now again, I've talked about Node-RED in previous projects. It's a brilliant piece of free software that's ideal for all sorts of home automation and device connectivity in industrial and scientific, lots and lots of uses. It's great for escape rooms as well. But this is creating a very simple text node in the middle here that counts the number of laps, and that just increments every time the mat is stepped on. I've also got a counter at the bottom here that gives me the time elapsed since the last lap was completed. So that's a very primitive lap counter, so every time I press it, this goes up. And here's the code that I've got running on the ESP device. So if you've followed any of my projects in the past, you'll know that I use a fairly constant structure for my code. We begin at the top with any external libraries that we're making use of. So the first library we need to include is the one that will enable the Wi-Fi network functionality. And like I say, I'm using an ESP32 chip, so the name of the library I need to include is just Wi-Fi.h. Now, this same code will actually work on an ESP8266 chip as well. That's a slightly older chip from Espressif, and that's the one that you'll find on WeMOS D1 boards and things like that. So if you're using one of those boards, the whole of the code will work fine. The only difference is that you have to include a slightly different Wi-Fi library at the top. So it's called ESP8266 Wi-Fi.h. So I've just got these little conditional lines here that says if we're targeting an ESP32 board, include this library. Else, if we're targeting an ESP8266 board, include this library. And from that point onwards, the whole of the rest of the code is identical. So this will work just as well on a, like I say, a WeMOS or a Lowlin board or something like that. It will work just fine. We then include a library called the pub sub client. You can download that from this GitHub link. This is a very popular client library for sending and receiving MQTT messages. So that's going to be the system we use for sending messages from the ESP device through to Node-RED, and that's what's going to display them on the screen. Again, I've spoken about MQTT in the past. It's a very lightweight messaging format, so clients and servers can publish messages to topics, and other clients can subscribe to those same topics, and every time someone publishes a message to that topic, if you're subscribed to it, you'll get notified about it. So it's a really good way of sending information, a kind of an ad hoc network, because you can have any number of clients subscribe to a topic, and you can have any number of different publishers sending messages to those topics, and you can send messages without even knowing who's going to pick them up or how many people are listening, things like that. It's very flexible, very ad hoc system. So MQTT is not the only way you can send information from an ESP device to Node-RED, but it's quite robust, it's simple to use, and it's efficient as well. So it's what I'll be using here. And again, if you're not familiar with that, it's a really good format to use in escape room automation as well. So that's the libraries that we're using. We then get on to the constants. So these are the variables that are not going to change throughout the duration of the project. So first of all, we'll define a few bits of the credentials for our Wi-Fi network. So this is the name of your Wi-Fi network, and this is the password you need to connect to it. And also, this is going to be the device on your network that is running the MQTT broker. So in my particular network case, I've got one other device other than the ESP. That's my laptop, and that is running Node-RED, which is running a local MQTT server. There is no particular reason that has to be the case. You could have your MQTT server on a completely different machine. You could have it on an external machine somewhere else on the internet and subscribe to that. But to keep this simple, I've basically just got a single server, if you want, or an MQTT broker. That's my laptop. And I've got a single client that is my ESP32 that's connected to the device. And in fact, I'm only going to be sending messages one way as well. So the client is just going to publish to the broker, and that is the only way I'm going to be sending messages. It's a very simple network topology in this case. I give my device a name. That's just to make sure it's uniquely identified on the network. And then we'll actually say what pin have we got the pressure pad sensor attached to. So it's wired between pin 13 and pin ground. Again, if you're not used to ESP devices, just be aware that the pin numbering is in a different layout, it's a different order than on Arduino devices. And in fact, it differs from one ESP device to the next as well. So make sure you search for a good pin layout diagram on the internet to make sure you're using the pin you thought you were. Then we get to the globals. So these are variables which are going to be shared throughout functions in our code here. So we'll create a Wi-Fi client, and then we'll create a pub sub client that is based on that Wi-Fi client. So what we'll do is we'll say, okay, so this is the general networking, and then this is kind of an interface to that network. We'll define a character array, which is going to store any messages that we publish over MQTT, and also the topic that we're going to publish into. So like I say, MQTT messages are structured around this idea of topics. And that's how you can control what you receive through the network, because you will only receive messages that are sent to topics you are subscribed to. We'll just record a last time this was activated. This is what we'll use to record our lap times. We'll just reset that each time a new lap is started, just to see the duration of each lap time. Okay, in setup, we'll begin a serial connection. That's just required for debugging purposes. We'll initialize the pin that the pressure pad is set to, and we'll initialize that as a pull-up, so that when the pad is not being pressed, it is pulled up to a high value. Because we've connected it between pin 13 and ground, when it's stepped on, it's going to be pulled low. We'll start up our Wi-Fi connection. So the ESP can actually function both as a Wi-Fi station and also as an access point. So effectively as both a server and a client. Can broadcast its own Wi-Fi hotspot. But in this case, we want to connect to an existing Wi-Fi network. So we'll set it to be a Wi-Fi station. We'll connect using the credentials we go at the top, and we'll just put it in a loop until we get the status message back that we've been successfully connected. Once we've been connected, then we'll register on our MQTT broker as well. So that's what we do here. We'll set the server to the IP address we include at the top, and that's the MQTT default port. And we'll assign a callback. So this is the function that's going to be called when a message is sent to any topic that we're subscribed to. And this just dumps a bit of debug information over to the serial connection, just so we know that we are online and what the IP address assigned is. Like I say, this is the callback. Now, in practice, in this script, the callback is not really going to do very much, because we are not going to listen on the ESP device for any messages sent to us. We are purely going to be transmitting messages to the broker when the pad has been stepped on. But there are circumstances you can imagine where you might want to send a message back from the server. Perhaps you want to have an acknowledgement system. Perhaps you want to be able to reset the device remotely. There's lots of examples. And when you do that, this would be the function that you do it in. So the MQTT callback, as we specified up here, this is the function that gets called every time a message gets sent into a topic that we're listening to, and you can access the topic it was published to, the content of the message itself, and how long the message was using these parameters here. But like I say, in this case, we're not going to do anything useful with it. Should it happen, we'll simply print out to the serial monitor connection what the topic was. But that's where you would add that functionality if you wanted to. We'll define a function called MQTT connect, and this is going to handle both the initial connection to the MQTT network, and then also if we need to reconnect at any point. So if we get dropped off and we need to reconnect, this is the kind of the series of steps we want to follow every time we connect. So a bit of debug information. We'll attempt to connect, and we'll use the device ID that we specified at the top. So this device ID here, this is the name we'll be using on the MQTT network. And what we'll then do, so this is where we configure what topics we are listening to and publishing to as well. So first of all, having connected successfully, we will publish a message. The content of that message will be just the character string connect, and we will send that to a topic that is defined here. So this snprintf function, what this does is it takes a string here, and it has a placeholder in that string, which is this %s sign. What that means is to replace that with the parameter we've got specified here. So this is literal text, so this will be toHost stroke and then the device ID. And again, the device ID is the same device ID we had here, and that is ESP32 lap counter. So what this means is our topic structure it begins with toHost, and that is any topic that begins toHost is going to be what the host will listen to messages published on, because that knows that that means it knows that it is in a message intended for the host. The stroke here, this is just like a folder separator when you're navigating through a directory structure. So this is going to be a subtopic, and the subtopic name is going to be the device that sent the message. So just from looking at the topic structure itself, the host can subscribe to every message intended for it. That's this first bit here. And it will also tell it who it was sent from, because that's going to be the bit after the stroke. And the message content is going to be what message is this device here trying to say to the host. Well, in this case, we're going to say that we have connected successfully to the network, so we'll issue this message called connect. So it's a little bit complicated if you're not familiar with networking terminology there, but it's really just, you might be familiar with the terms handshaking, things like that. When networking devices first establish a connection with each other, it's quite usual to issue some kind of exchange between them just to let them know that they're online, and that's the purpose of this section here. Like I say, we will also then subscribe to some topics that are meant for this device. Now, when we send messages to the host, we send it to host. However, when we want to receive messages, we'll subscribe to device instead. And which device do we want to subscribe to? Well, to the device ID of this device. So if any other MQTT client on this network sends a message to the topic to device / and then ESP32 lap counter, which is what device ID is, we will pick up that message, and this is what we will do with it. Now, like I say, in this particular example, I'm not really actually making use of that function, but that is how you would do it. And we'll finally subscribe to one more topic, which is to device all. So the idea here is that every device on the network can, if you want to publish basically a global broadcast message to every device, you send it to this topic here, and everything will pick up those messages here. So this is a topic specifically for messages to the host. This is a topic specifically for messages to a named device, which is going to be this one here, and this is for all devices to listen to. And again, that's not the only way you can structure MQTT messages. You can do it however you want. This is a structure which I have used in production cases and works well for me. So that's just my recommendation. But you can do it however you want. And then this section here, well, this is what gets called if we were unable to connect to the MQTT network. So again, we'll just put out some serial information there. And then finally we get onto the actual main program loop at the bottom. So this is what's going to be stepped over and over while the code is running. So what are we going to do? Well, first of all, we'll find out how long the code has been running for. So that's what this minis function tells us. And we'll store that in a variable called now. Then we'll find out, well, actually has the pad been stepped on or not. So we'll do a digital read of the pin which the pressure pad has been connected to. Now remember that this is defined as an input pull-up, this pin. So when it is not connected, it's going to read high. When the pad has been stepped on, what it's going to do is it's cause a connection through to ground, which means it will read low. So that's what this message does. So when it reads low, that means the pad's been stepped on. So the next thing we'll do, we'll compare whatever the time is now, that was this one here, to whatever the last time the pad was stepped on. And if it's greater than 1,000 milliseconds, so basically if it's been more than a second since last time we recorded a step, then we'll publish a message. And this time we'll publish a message to the host, again, from this device ID. So we'll say which device was sending a message. And the message this time is going to be the single word lap in capital letters. Okay, so we sent connect when we first came online, and now to the same topic we're sending lap. Then we update the last time and we go through again. So the reason for this section here, this is basically to prevent double counting. If that wasn't there, then if you stood on the mat and stayed still, this would generate a new MQTT message every time the loop function got called. So this is sort of thousands of times a second you would be recording a new lap. This is a kind of a primitive way to make sure that you have stepped off the pad for at least a second before stepping back on it again and recording a new lap. So that's the purpose of this line here. Then what we'll do is we will just check that we are connected. So if the loop function ever gets called and the situation is that we're not connected to the MQTT network, then we'll call the connect function. That was at the top here. So, if you had a perfectly reliable network that never dropped out, in theory you could call this once in setup at the beginning and never again. But this is kind of more best practice, basically, to put it in loop function and just to check on every frame that you are still connected, because that will automatically reconnect if for whatever reason you get dropped out. And then we actually call the loop function itself. Now this is a bit confusing. We've got a loop here. This is the main program loop. But the MQTT client, which we defined at the top of the code here, this has a loop function as well. And you need to explicitly call that on each iteration of loop. And what that will do is that will do things like check for any messages that was intended to us. If there are any messages queued up to be sent, it will actually deliver them. It will perform all of the networking refresh functions for you. So it's not sufficient just to have an MQTT client and to do this sort of subscribe and publish things. That's all very well, but to actually get those actions executed, you then need to call the loop function itself on each iteration of your main program loop. And that's it. And here is the flow which I've got running on Node Red, which is what's controlling the actual lap counter on the screen. Now again, if you've not used Node Red before, I am a massive fan of it, and I do encourage you to check it out. It's free. It was originally developed by IBM, and it lets you kind of create these graphical drag and drop flows that define how devices connect to each other, how they trigger events, how they pass data along between different devices, things like that. It's very powerful and it's pretty easy to use. So generally speaking, you can think of one of these flows as going from left to right, and it passes through kind of different nodes along the way, which does different functions to the piece of data that gets passed to it. And that's how I've got mine set up here. I've got a couple of nodes at the top here that aren't connected to a flow. So these are initial configuration nodes, a little bit like the setup function that you imagine in an Arduino code. It gets run once at the beginning and then not called again. So I've got two nodes here. This first one is called Mosca, and this is the MQTT server that actually runs within Node Red itself. So rather than using a separate MQTT server like Mosquito or something like that, you can actually install an MQTT broker from within Node Red. So if you search for Mosca, you'll find it's this module here, Node Red Contrib MQTT broker. And so with that running, you've actually, every time your Node Red instance is running, you've got an MQTT broker running as well, and it's kind of one less thing to configure. So that's that one, and I just defined the basic. This is just all default settings for what that server configuration is. I then also got a little bit of CSS style. So the dashboard, which I'm going to be displaying at the end on the screen, where I've got that large lap counter and I've got the background color and things like that, that's just an HTML page. So what I've got here is I've just got some CSS styling to say what color I want the background of that page to be, how big I want the text item, so the lap counter itself is going to be centered and 700 pixels high. So this is just standard CSS styling as well. So again, I define that once at the beginning of the code, and I define the MQTT configuration at the beginning of the code. And then we get on to the actual, the sort of the flow of information itself, I suppose. So a flow starts with something that kind of triggers it off, and I've got two potential sort of causes of things to start. One of this is on initialization. So this is a trigger node that gets called when the code first gets initialized. And what we're going to do there is we're going to create some global variables. So we'll initialize the number of laps completed as 0. And we'll also say that the time of the last lap being completed was 0 as well. So this is no different from setting variables in Arduino. And we'll set these as part of the flow context. So Node-RED has this idea of different contexts within which variables can be set. And this is much like, again, in any other programming language, you can have local variables which are specific to a particular function, or you can have global variables. And flow is a little bit like a global variable. So I'm setting it in this node here, but I'll be able to access it in any other node that is on the same flow tab as this one. So I've called it global variables here, but the Node-RED terminology means that it's a variable set in the flow context. That's what we mean there. And then the line going off from that, well, that goes to this template node at the end. So template is one of the dashboard nodes, which we've got down here. And again, these effectively let you create all different sorts of HTML elements. So if you're familiar with making web pages, you know about things like forms and buttons and drop downs and text and all the rest of it. A template is like a free form HTML content. So I've put an image in, and I've put a URL for the source of that image there. That's my little NHS rainbow flag. And then I've got just 2 paragraph nodes, one of which is containing the number of laps completed, and one of which is containing the timer text. And these, you'll notice I've got these in this sort of double bracket, double curly brace syntax here. That is to show that this is a placeholder that's going to be replaced with a value that was sent in from the message that's been passed through the flow. So I've got this initialization connected here, just so that will kind of populate the template when the code is first started up. But that message value there is going to come from this lower down sort of series of nodes here. So let's see what starts these off. So this is a different type of trigger. This is the on message received. And this is a flow that is started when an MQTT message has been received in a particular topic. So just like in our ESP code, if you remember, we subscribed to particular topics that were to device, /, and then the device ID. Here we're going to subscribe to any MQTT messages published to the to host topic, and then any subtopic of that. So that's what the little hash symbol here means. And you'll remember from the ESP code that the hash will actually get populated with the ID of the device that sent the message. In this case, we've only got one other client, which is the ESP32 lap counter, so that will always be the same. But just as a general extendable kind of format, we'll put a hash there so that any device on the network that wants to publish a message to the host can set it to its own subtopic of the to host channel, and the host is going to pick it up here, and that is going to start this flow off here. Okay, so we've received a message published to the host. The next thing we're going to do is check what the content of that message is. So we'll use a switch node here, and we'll look at the payload of the message. So the payload basically just means what was the content of that MQTT message that got published. And if you'll recall, our ESP32 publishes 2 types of messages, or 2 contents of messages. It says either lap, that's when the sensor is pressed, every time it's pressed down that gets published, or it says connect, that was the initial message that got published when the device first comes online and it connects to the network. And the point of a switch node here is that we can divert the flow down different channels depending on which of these conditions is met. So if the MQTT message payload was lap, we're going to send it to the first output. That's this high up one here. If it was connect, we'll send it to the second output. And you can add as many of these additional conditions as you want. So you can send, as many different types of payload messages as you want and divert the flow into different ways. This is what's so nice about Node-RED. It's so simple to kind of understand and to create quite complex conditional code logic, but kind of laid out in a nice graphical way. So let's actually look at the second case to start with. So that comes down here to this node here. And this is what's called a link node. So generally speaking, when you have nodes connected in a flow, you have these kind of solid lines connecting them here. Like I say, you can imagine the message being passed down the flow from left to right. But sometimes when you have complicated flows, you can get kind of weird crossed lines. So a link node just makes, it's a convenient way to lay out more complex flows. And in this case, I've got a link out here that's connected to this link in here. So links come in pairs. You have a link out and a link in, and they go together. And what's happened here is that my connect message starts off the same flow as my on initialization message did here. So this is just to say basically a new client has come online. Okay, well let's do the same thing as when we actually started up the server at the beginning. We'll initialize all of the variables again. So that's what connect does. Connect, when a new client comes online, calls the same flow as what happened when the server first came online. That's the point of this link here. Okay, now let's look at the other example. In this case, that's when a lap message came in. So that goes out of this first output here. And in fact, the first thing we do there is split this into two different channels. So these are going to be executed concurrently. And the one at the bottom here, well, this is going to play a sound file. So I use a file node, that's this one here, to load an MP3 file. And then I pass that MP3 file to the audio out node. So that's going to play this out of the just default speaker attached to the device whenever the lap is set off. And then I'm also going to call this top branch here. And what we're going to do here, I've got a series of function nodes. So let me just talk through each of those in turn. The first one, we're going to get the global variable for the number of laps completed, and we're going to increase it by 1. This little thing here, this just lets us, this is a little bit like kind of debug.log in Arduino, I guess. It lets you see underneath a node in the graphical editor here, it will display a little value. So we're going to display the number of laps completed. We'll also color it green. That just lets us kind of debug what's going on as the flow is running. Having incremented the number of laps, what we need to do is we need to set that back in the flow as well. So we'll retrieve what the old value was, increase it, set it back again, and then what we need to do is we need to pass that updated value down the flow to the next node. So that's what we do here. We assign the message context this time. This was the flow context because we retrieved the global variable and we've updated that, but we also send it down this particular branch of the flow as a message context variable. So we've increased the lap counter. Now what we need to do is calculate how long it took to complete that previous lap. So we look at the next node along the flow, and what we do here is we retrieve the current time. So date.now, that's very similar to the millis function which we used in Arduino. That gives the timestamp of the current time. We'll then retrieve the timestamp of the last lap again. So this was a flow context, so like a global variable. And we'll work out the elapsed time by subtracting the time at which the previous lap completed compared to the current time. And we'll pass that along the flow. So we'll create a new message parameter called time. We'll pass that in the message context, and that's equal to the elapsed time that we just calculated. Again, we'll just put a little bit of kind of debug information in the node status to say what that value was. And we will reset the flow context variable with the updated value of what the current time was as the timestamp of the last lap. And the last node in this section of the flow is to actually format that information appropriately so that it can be sent to the HTML template node there. So what we do first of all is we look at how many laps have been completed so far. So we retrieve the flow context variable. And essentially we don't want to display the time taken until we've actually completed a certain number of laps. When you're on your first lap, you can't display, how long did the 0th lap take. So we'll, so long as the number of laps completed is under 2, we'll overwrite the timer text of the message and we'll just put a blank there or something like that. And then we'll return straight from the function there. If it is greater than that, however, what we want to do is to format the message timer text into a nicely formatted kind of minutes and seconds and milliseconds variables or something like that. So that's what the next section will do. So at the moment, when this node gets called, message time was calculated here as the difference between two timestamps. So currently, message.time is a value in milliseconds. And what we want to do is to format that kind of nicely into 2 decimal places of minutes, 2 decimal places of seconds as well. So that's what we're doing here. First of all, we'll divide it by 1,000. That gives us a value in seconds. And then we will work out the hours, the minutes, and the seconds of that by a combination of divisions and modulos. This is a standard way of doing this whenever you're trying to convert a timestamp value into hours, minutes, and seconds. This is a very standard function that is used here. And then we'll format that into a nice string value. So we'll pad it with leading zeros. That's what this bit here does for the minutes and the seconds. Again, we'll update the node status and we will forward the message on down the flow, except this time message.timerText now features this nicely formatted value, which means that it can now be picked up by the template node at the end and substituted in place here. And that's all it does. So that is my ESP32 lap counter project. It's a slightly different application from normal, but hopefully you will have been able to pick up just part of that you will be able to take away and use in your own projects. I'd like to thank and congratulate Captain Tom Moore for the amazing job he's done raising almost £30 million to the NHS, and also to thank everyone in the NHS and to medical and key personnel all over the world, whether you are a delivery driver or a postman or a farmer or a teacher. There's lots of amazing people doing amazing things everywhere right now. Thank you so much and stay safe yourselves. My next video will be back to being a slightly more traditional escape room project, I hope, and I look forward to seeing you then. Okay, thanks very much for watching.